Hi everyone, here's a tutorial from some of the problems from the book Advanced Engineering Mathematics 5th edition. For our first problem from page 107, number 66, find a complete solution for the equation y double prime plus 2ay plus quantity a squared minus b squared times y equals f of x. First, we obtain the auxiliary equation, and for this problem we have m squared plus 2am plus a squared minus b squared equals 0. By using the quadratic formula, we let a equals 1, b equals 2a, and c equals a squared minus b squared. And we can solve for the roots. For m sub 1, we have m sub 1 equals negative 2a plus square root of 4a squared minus 4 times 1 plus quantity a squared minus b squared all over 2 times 1. By simplifying it, we get m sub 1 equals negative a plus b. For m sub 2, we have negative 2a minus square root of 4a squared minus 4 times quantity a squared minus b squared over 2 times 1. And we get m sub 2 equals negative a minus b. And since we have distinct roots, we know that the complementary equation for that is y equals c1 e to the power of m sub 1 times x plus c2 e to the power of m sub 2 times x. And for our final answer, we therefore have y equals c1 e to the power of quantity negative a plus b times x plus c2 e to the power of quantity negative a minus bx. For problem number 2, for the given spring mass system, find the displacement y as a function of time, given the weight equals 40, k equals 20, y sub 0 equals 2, and v sub 0 equals negative 8. We know that for a spring mass system, we have the equation m times d squared y over dt squared equals negative ky. So now we solve for m, and by substituting the values we get m equals 5 over 4. And we substitute that values to the equation, and we get 5 times d squared y over dt squared plus 80 equals to 0, and that is our equation 1. For an undamped system, we know that the complementary solution is equal to y equals a sine omega t plus b cosine omega t. By solving that, we get our complementary solution y equals c1 cosine 40 plus c2 sine 40, and that will be our equation 2. Now, we substitute the initial values y sub 0 equals 2 and t equals to 0 from equation 2. And we get 2 equals c1 cosine 4 times 0 plus c2 sine 4 times 0. By simplifying that, we get c2 equals 2. And now, by differentiating equation 2, we get y prime equals negative 4 c sub 1 sine 40 plus 4 c sub 2 cosine 40, and that is our equation 2. Equation 3. By substituting v sub 0, which is equal to y prime equals negative 8 at time equals 0, we substitute that from equation 3, and we get negative 8 equals negative 4 c sub 1 sine 4 times 0 plus 4 c sub 2 cosine 4 times 0. By simplifying, we get c sub 2 equals negative 2. Therefore, our displacement y as a function of time is equal to y equals 2 cosine 40 minus 2 cosine 40. And that will be our final answer.